Now let's talk about managing permissions. Basically, under permissions management, we are looking at how we can manage permission for files and how we can manage permission for users. This means that we are looking at which user can access a particular file, maybe which user can read from a file, or which user can write into a file, and then which user actually has permissions to access a file. So we are going to be looking at files permission, user permissions, and read write. Let's start with file permissions. As far as the Linux permission system is concerned, there are three main permissions associated with the file. So there are three types of permissions associated with the file as far as the Linux based system is concerned. So if you have your file here, maybe file.txt, there are three major permissions that could be associated to this given file. This file could still be a pod.yaml file, or this file could still be a Jenkins file, whatever the case. Assuming you have a file like this, what are the key permissions that could be associated with this file? The key permissions which can be associated with the file, we have the read permission, abbreviated in the Linux system R. We have the write permission, associated W, and then we have the execute permission. As far as the Linux system is concerned, you always see R for read, W for write, and X for execute. So let me see, emphasize that this is read, this is write, this is execute. Those are the key permissions that pertain to a file. Who can read this file, who can write into this file, and who can execute this file. So those are the key permissions with respect to a file. Now, also looking at this file, we also have the category, a different category of users that can access this file. So for a given file, say a pod.yaml file, or a Docker file, or a Jenkins file stored in your environment, which users in your Linux operating system can access this file? So that is another level of permissions. Which user? So we are also looking at user permissions. And as far as the users that can access the file is concerned, we have the owner of the file, the owner of the file. We have the group to which the file belong, the group to which the file belong, the group of the file, and then we also have other users. So take note, we have owner of the file, the group to which the file belong, and then the other users. Those are the key category of users that can actually access a particular file. Now, let's look at symbolic location. Let's look at permissions notation. So how do we represent permissions in the Linux operating system? For us to represent permissions, there are two key ways. First, we have the symbolic notation. And with the symbolic notation, it consists of three categories: the owner, the group, and then others. With respect to our previous notations, we said R is for read, W is for write, X is for execute. If you have a dash, it means no permission or a permission was not granted. So for us to represent permissions with notation, you always see permissions represented with three chip with the following notation. So we have 1, 2, 3 for the owner, 1, 2, 3 for the group 1, 2, 3. So there'll always be this pair of this permission set if you are using the symbolic notation. Let's take a practical example. We have R, W, this, and then R, and then now this is the default, meaning no permissions granted. Assuming you have an example like this, we have the first three, the second three, and the third three. So this means that the owner has read and write permissions. This means that the group has just read permission, and then this means that the other users have read permissions. So this is basically how you represent this. For another case, we might have read write, we might have read write, and then we might have read execute, then dash no permissions. Now this will mean that the owner has read and write, the group has read and write, and then the other users have read and execute. So this is a symbolic notation. So you can use these letters to symbolically represent the permissions which users have. Still looking at permissions notation, the second which we have is numeric notation. So let's have this, let's still have this at the back of our minds, where R signifies read, W for write, and X for execute. Now with the numeric permissions, read has a numerical value of 4, write has a numerical value of 2, execute has a numerical value of 1, and then no permissions has a numerical value of 0. Now let's take the previous example we had where our permission set was read write dash read dash dash and then read. Now in this case, the owner, if we are to use numeric notations, the owner has, these permissions will be 6, and then the group has, so you take the sum of these will give the value for this first octet. You take, so that you take the sum, you take the sum, you take the sum. So if I'm to use this notation, this will give me 4 plus 2 plus 0. This will give me 4 plus 0 plus 0. This will give me 4 plus 0 plus 0. This means that my permission set will be 6, 4, 4. Meaning, instead of me writing RW dash, then RW dash dash, RW dash dash, I can represent this simply using 6, 4, 4. So that is how we get numerical values for permissions. So you must remember that the sum of these first 3 digits gives you the numerical value. The sum of the second 3 digits gives you the second numerical value, and then the sum of the third three digits gives you the last numerical value. So how do we change permissions? We have changing. For you to change the permission for a file or for a directory, we use the chmod command. So chmod, chmod, the chmod command is a command used to change permissions. Let's take a simple example. Assuming you want to give a user read and write permissions. For you to give this user read and write permissions, you use the command chmod, and then you use u to indicate user, and then you say you're adding the permissions read and write. So this means that the user will now have read and write permissions. And if you were to do that, maybe using symbolic notation, that would be chmod user plus rw. If you were to do this using numerical notations, this will be chmod, and then this will just be 6, since we have read as 4, write as 2, and if you sum these two, you have 6. So the user plus r is to add permissions. Now, to remove permissions from the user, you use the same command chmod user minus read write. So if we were to use the same numerical notation, we'll have chmod u minus rw, or chmod u minus 6. So to add permissions, you use the chmod u plus r, and then you specify the permissions. So to add permissions, you use the command chmod u plus permissions. This could be read, write, execute. And then to remove permissions, you use the command chmod u minus permissions. This could be read, write, execute.
We are back on our terminal and we'll be looking at permissions. Permissions for both files and directories. So like I mentioned, for you to know more about permissions that currently exist, let's do an ls to see all the existing files in our current directory. So we do an ls. We see we have AWS IAM Authenticator, kubectl, random 3. If you're actually just creating an instance, you will not have any of these files. So you can actually, there's no problem if you don't have any of these files. You can create your own set of files. So these are different files and directories that we have in our system. So for you to see the various permissions that each of these files have, you do an ls-l, and you'll be able to see all the permissions. So this first set of letters you have here, or this set of string, represent the permissions which a given file has. This represents the number of hard links to the file. That's in case the file is used only in one place in this given directory. This represents the owner of the file, and then this represents the group to which the file belongs. This represents the size of the file. This represents when the file was created, and then this represents the time which the file was created, and the file name. Now take note, the dash here is representing files, and then the D here is for a directory. So the D represents that we're looking at permissions for this directory. So this will be the set of permissions that this directory has. And then this one, a number of hard links that are actually connected to this directory. We have the owner of the directory. We have the group to which the directory belongs, the size of the directory, when the directory was created, the time or the date, and then now the name of the directory. So let's go ahead to actually create our own files and then try to work around permissions for those given set of files. So let me clear this. Let's create two files using the touch command. So let's touch testing file.txt. Let's create another one, touch testing file 1.txt. So we have two new files, testing file and testing file 1. So let's do an ls to be sure. If you do an ls, you see we have testing file 1 and testing file. Let's also make two directories. So let's make a directory testing for our testing environment, and then let's make another directory production for our production environment. Now, if we do an ls, we have two new directories: production directory and testing directory. We also have the testing file and the testing file, the two testing one and testing two files that we created. Now, let's do permissions. Let's do an ls all to see all the permissions that these files have. Now, if you look at this testing user, the first set of permissions here, we see that the owner of this file has read, that's EC2 user, who is the owner, has read, write permissions for this file. If you look at the second, the group has read, write permissions, and then other users have just read permissions. If you come to the testing folder, which we also created, the testing folder, which is a directory, you see that the owner has read, write, execute permissions. The group has read, write, execute permissions. And then other users have read and execute permissions. So those are the first set of permissions that you should understand. So let me clear this. Let's do an ls all again. An ls all. Now you see that we have two files, testing one. They both have the same permissions: read, write for the owner, read, write for the group, and read for other users. Now we are going to be doing a lot around understanding these permissions. So let's go ahead to manage permissions for the file testing file. So let's manage permissions for the file testing file. We are going to start first by giving the owner read, write permissions. Remember we said we can assign permissions using the chmod command. So for us to do that, you did chmod, and then you do user, and then you do u, and you give the permissions read, write. Oh, we did not specify the file name. We do that again. Chmod u plus we give read, write, and then we specify the file I want to give to testing file. So this is the file that we are giving the permission to. You now see we have added read, write permission to the owner. So let's do an ls all to see the permissions. If you come to testing file one, you see it has the read, write. The user has the read, write permission. Now let's add the read, write permission to the group, where the group already has read, write permission. Let's remove the write permission from the owner. So to remove the permission, like we said, let's do an ls all again. Now we see the user has the read, write permission. The group has read, write permissions, and then others have read permissions. Let's add write permission to others. So to add write permission to others for that file, we say chmod. We are now adding it to others. So it's O plus we want to give the other write permission, and then we specify the file name testing file dot txt, and you hit enter. Now if you do an ls all again, you will now see that the user for this testing file now has write permission added. You now see that the user has write permission added. Now let's remove the write permission for all the user, the group, and the owner. So we start by removing the write permission for the user. For us to remove the write permission for the user, you do chmod user minus write to remove the write permission, and then specify the file testing file.txt. Hit enter. To confirm, you do an ls l. We now see that the user no longer has write permissions. Let's clear. Let's do an ls
L again. Let's now remove the write permission from the group. So for you to remove the write permission from the group, you do chmod group minus W. That's, you are removing the write permission, and then you specify the file testing file.txt. If you do an ls all, you will now see that the group does not have write permission. Now let's remove the write permission too from others. So we clear, we do an lsl. Again, we want to remove this write permission from others. For you to remove that, you do chmod o for others, you subtract, we are removing the write permission, and then you specify the file that you want to remove the permissions from, that.txt. And then you see, if you do an ls all again, we realize now that we have removed the write permission for all these users. Again, to understand how to add permissions, let's add the write and execute permission to all the files. So let me do an ls all again. Let's add the read and write permission to the testing file. So to do that, we do chmod. We start with the user, and then we are adding write and execute permission, and then you specify the file testing file.txt. We continue. Let's add the same thing for the group. So we do group, and then we add write and execute. We specify the file name file.txt. And then now let's add for the other users. So you do chmod group o for others, and then you add the same write and execute permission for others. With that, if you do an lsl now, you realize that they now have read, write, execute permission, read, write, execute permission, and read, write, execute permission. So let's clear this. To increase space, let me do an ls. I want us to remove some directories, so let me remove the Kubernetes file or kubectl. Let me remove the renamed.txt. Let me remove the random3.txt. Let's do an ls. We now have fewer files. Let me remove the Redis file. Let me do an ls. We now have fewer files. Let me remove the IAM authenticator. If I do an ls, we have fewer files. Let's remove the Redis directory. So to remove the directory, we take rm r, and then we give the directory name Redis. That I do an ls, we no longer have the Redis directory. So let's do ls all to see the various permissions. Now let's play around the testing directory. Let's remove the write permission on all these. Let's remove the write permission for the user, the group, and others. So to remove that, we do chmod. We start with the user. We are removing the write permission for testing. You will remove that permission. So if you do an lsl, you see that the directory testing no longer has write permissions for the user. Let's also remove for the group. So to remove for the group, we do chmod, and then we remove -r, chmod group -r, and then we specify the directory name testing. So you see, if you do an ls or, we have removed the write permission for the group in the testing directory. Let's also remove it for the other users. So you do r chmod o for others, and then now you remove the write permission, specify the directory name, and you hit that. So if you do ls l, you realize that we have removed the write permission for all users, group, and other users for the testing directory. So that is how you can remove, or you can play around permissions using the symbolic notation. Now let's understand how to use numeric notations to manage permissions. So let's do an LSL again. Now let's use the production folder in this case. We are going to be managing permissions using numeric notations. Remember, the first three, the sum of the first three here will give the first number. The sum of the second three here will give the second number. And then the sum of the third three here will give the third number. Now, let's remove all permissions for the user and for the group for the production folder. So if you are to remove them, that means this will be 0, this will be 0, and then the remaining permissions will be maintained for the user. So for you to do that, you do chmod. Since this is all the full permissions, that means it will be 700 because it will be 4 plus 2 plus 1, which will give us 700. 7, which will give us 7. And then if you have to remove permissions for both user and group, the value here will be 0, 0. And then you specify the folder. This will remove all the permissions for the group and the other users for the production folder. So if you do LSL, you now see that there are no permissions for the group and no permissions for others. For you to add, say, read and write permission for others, you go ahead to chmod. You maintain the 7 all permissions for the user, 0 no permissions for the group, and then you want to give read and write access for others. So to give read and write access, that will give us 6. So we have 706, and then you specify the folder production and you hit enter. So if you do an LSL now, you now see that the production folder has read write access for others, no permission for the group, and then all permissions for the users. Now, one of the common permissions you always come across is the chmod 400. So assuming you want to log into an EC2 instance subsequently, you'll be using the chmod 400 command, and chmod 400 basically means you want to give that folder just read permission. So if you have to give the production folder 400, we'll now have chmod 400. You specify the production folder. So the production folder will now have only read permissions. So you can only read from this production folder. So you mostly see chmod 400 in your environment. You also see chmod 700, which is read, write, and execute permission. So that is basically how you can manage permissions as far as directories and files are concerned using both symbolic and numerical notations with the Linux system.